All right, so question number 4 says this question is about the process of controlled nuclear fission in a nuclear reactor. In a nuclear reactor, uranium-235 nuclei are split to produce daughter nuclei and neutrons. State what else is released in nuclear fission that makes the process useful in a nuclear reactor. So fission, the word fission basically means that to split. So a split word has another meaning called fission, right? So what do we do here? We split the nucleus of uranium-235, one of the nucleus of uranium-235 that produces daughter nuclei and some neutrons. There is something else that is also being produced, and they have asked you what other thing is being produced. So let's go and see the entire process of a nuclear reactor and how it's working. Here, let's see. This is the core or main part of the nuclear reactor, and it is connected to a boiler. This particular boiler has water that we heat up, and we will see how the heated up water is used later on. First of all, this core part. This core part has fuel rods, right? It has the three main things here are the fuel rods, the moderator, and the control rods. These three are the main. Okay. So first of all, the fuel rods. These fuel rods are made up of uranium-235 atoms. So it contains uranium-235 nucleus, right? And there are slow-moving neutrons. And note that it has to be slow. I will tell you why later. Slow-moving neutrons. These slow-moving neutrons travel and hit the nucleus of uranium-235 in the fuel rod. As a result, the nucleus of the uranium-235 atom breaks or splits. This process is known as fission. As this particular uranium-235 nucleus splits, it forms two daughter nuclei, which means two more nucleus, right? Plus some neutrons. Usually it's like 2 to 3 neutrons, right? So neutrons plus neutrons plus neutrons. Plus it produces kinetic energy, either like it produces energy, okay? Now this energy can be in terms of kinetic energy or thermal energy. Let's call it thermal energy. So it produces thermal energy. Now, these neutrons that have been produced, they travel again and they hit more uranium-235 nuclei, right? They will go and probably this will hit another uranium-235 nuclei, this will hit another 235 nuclei, and each of this the uranium-235 nucleus will produce more daughter nucleus, plus they will produce more neutrons, right? So this process will continue, and this is known as a chain reaction. Like it's being continuous, so it's known as a chain reaction. Now, what do? We use up this particular thermal energy that is being produced. This thermal energy causes the water in this particular boiler to heat up. It heats up this particular water. So as the water heats up, it produces the water becomes steam, right? What are steam? Steam are fast moving particles. So this steam are fast moving particles, which is then in turn connected to a turbine. A turbine probably looks something like this, right? So this fast moving particles will come and hit this particular turbine. As a result, the turbine will start to rotate. As the turbine starts to rotate, it is connected to a generator, right? So as this starts to rotate, it causes the generator to rotate as well, and it causes the generator to start up. As the generator starts up, it produces electricity. And that electricity is then passed to the national grid, and from the national grid, it comes to the consumers, right? So what do we have here? We have from chemical energy in the fuel rod to thermal energy that is being produced, to kinetic energy of the steam, to kinetic energy of the turbine, to electricity, right? This is the energy transfer that is happening here. So the other thing that they had asked us was thermal energy. In the next two questions, they have asked us the function of control rods and moderator. So let's go back to this diagram. First of all, let's come to the moderators, okay? So what does the moderator do? The moderator is mostly made up of graphite, okay? And these moderators always slows down these neutrons. So if we have any fast moving neutrons, they will always slow down the neutron, because if the neutrons are not slow enough, the fission reaction will not be efficient. Okay, so we always need slow moving neutrons, right? So moderator slows down neutrons so that the chain reaction is very much efficient. And about these control rods, these are rods that are at the top of these particular moderators, right? And control rods can be inserted and it can be pulled up as well. So whenever you need the reaction to, this is basically controls the reaction. Since the name is control, so it controls the reaction. How? If you want to stop the reaction, you will insert these control dots inside, right? You will insert these control dots. Once you insert these control dots, it will absorb the neutrons. So if there are not enough neutrons, then there will not be enough fission reaction. As a result, there will not be enough thermal energy to cause the further reaction to occur, right? So the control rods can be inserted. Once they're inserted, they absorb the neutrons. If the neutrons are absorbed, then there are less number of neutrons, and as a result, the reaction slows down. Or if you pull up the control rods, there are more number of neutrons. As a result, the fission reaction continues and the fission reaction is fast. So you can control the reaction, the rate of reaction, whether you want it to be fast, whether you want it to stop completely, by using this control rods. Now let's get back to the question. What is the function of control rods? We have just learned that the control rods absorb excess neutrons. And what is the function of moderator? Moderator slows down neutrons. Done. Next, many of the daughter nuclei produced in nuclear fission are very radioactive. These daughter nuclei decay by emitting ionizing radiation in a random process. State what is meant by ionizing radiation. All right, this word ionizing is very familiar from chemistry, right? Ions basically mean charged particles, right? So ionizing radiation, this is a type of radiation where you knock off an electron from an atom. So if you have an atom and you knock off an electron from there, this particular atom is losing an electron, right? Once an atom loses an electron, it becomes a positive ion. This formation of positive ion is known as ionizing radiation. Now, there is only one difference that you will find here, and that is ionizing radiation. Here, I have only talked about positive ions, right? Because it's always the knock off of an electron. It's always the removal of an electron. So if an electron is removed, the atom will always form a positive ion. There is no formation of negative ions, okay? So what can we write? We can write that ionizing radiation is a type of radiation where an electron is removed from an atom, turning it into a positive ion. Done. Now, next I have asked, state what is meant by the term random process. Random process basically means something you do not know exactly when or what is going to happen. Like, you know what is going to happen, but you exactly do not know when something is going to happen. That is random, right? So in this case, what does the definition say here? Many of the daughter nuclei produced by the nuclear fission are very radioactive. This daughter nuclei decay by emitting ionizing radiation in a random process. So the action here is the nuclear decay. So random basically is meaning here that you exactly do not know when a nucleus is going to decay. It does not follow a particular pattern, and that is known as random process. So we can write here that it is not possible to know when a particular nucleus will decay because radioactive decay is unpredictable and has no pattern. Having no pattern means that something is random. I hope this makes sense. তারপরে going to this, the diagram shows some parts of a nuclear reactor, and you are asked to explain the role of the shielding in a nuclear reactor. So this particular concrete kind of thing that is covering the entire components is known as the shielding of the nuclear reactor. So what does the shielding do? Basically, when there is when fission reaction takes place inside this particular reactor, a lot of radioactive elements are being released, right? So that radioactive elements are actually really harmful for the human body. Not for only human body, any kind of living things. For any kind of living things, it's harmful. It can cause cancer, mutations, and a lot of different things. So in order to save us or save the people who are working around it, they have built this particular shielding, concrete. This particular shielding absorbs most of the radiation that is being produced by the nuclear reactor. So if it absorbs most of the radiation, then of course the harmful effect of the radiation decreases by a lot of levels, right? That is what the shielding is doing here. So that's what we're going to write here, that radiation emitted in a nuclear reactor is harmful, so it can damage cells or cause cancer. Thick shielding absorbs or blocks the radiation so that little or no radiation reaches workers outside the reactor. We are done with question 4.